Okay, so today we will be discussing on electricity and for electricity, right, what are the main few aspects to know? So usually it begins with you need to know how to go about drawing the different symbols of the different operators of electricity. And over here we do see that there is actually a few of them in which you will have to remember. Like for example, for cells, right, cell, right, cell represents only one battery. And in this case, right, you will also need to distinguish between what is the long line and what is the long line and what's the short line. So the long line would represent the positive terminal of the cell, whereas the shorter length will represent the negative. And when you are required to draw multiple cells connected together, it's always of alternate in terms of the long and short. So this would mean that the positive and negative will always be different or alternating. Okay, if a battery, if you were to draw it in this manner, this will not allow current to flow through and you'll be marked wrong because the terminals are actually of the opposite. Similarly, if it's in this fashion, it will also be marked wrong because both are not able to actually display or allow current to flow through. Another apparatus that usually you will connect to in an electrical circuit, right, is actually a light bulb. And this is annotated with a circle and a cross in between. Okay, so this represents a light bulb. For a switch, an open switch is whereby you would have two open circles and the line doesn't really touch each other. Now, in this case, when it's open, right, current is not able to like bypass, it has to, and hence this is what we call an open circuit. An open circuit will not allow, let's say, the battery to light, the light bulb to light bulb because current is not able to flow through. A closed circuit, on the other hand, or the switch that is closed, will be represented when the lines are actually stuck to each other. Okay, so that is when the switch are closed. And you also have the resistor. So resistors, there are two types of resistor, a fixed resistor and a variable resistor. So how is it different? For a fixed resistor, you will see that it's represented by a rectangle box. Okay, you must use a ruler to draw all these. Okay, it's a rectangle box and this is a fixed resistor in which the resistance will not change at all. However, for a variable resistor, it has to be drawn with a diagonal arrow upwards. Okay, and this is usually what happens. Next, we look at the other types of meters that will actually go about. So the resistors, they don't really measure, they actually control the amount of current through the resistance. And the meaning of variable means that it can actually change. Okay, next, how do we measure the current as well as the voltage, which we will cover later on? It's through the use of the ammeter and the voltmeter, respectively. So, how to represent the ammeter is just a circle with the letter A inside. Okay, and the voltmeter would be a V with the circle with the circle surrounding it. A fuse is actually a component in the electrical circuit such that if let's say there's too much current flowing through it, this fuse will actually break and hence cause an open circuit. Therefore, the current will not be able to flow through properly. So electricity is the flow of electrical charges, and that when electrical charge flow, they will actually carry energy known as the electrical energy or electricity. Therefore, electricity is also another form of energy. This electrical energy would change into other forms of energy when it flows through the electrical appliances. Okay. So for electric circuit, right, a basic electric circuit will contain a conducting wire, a switch, an electrical component, and an electrical source. Now, all these are different parts of it. So what's the wire? The wire is the pathway in which the current is able to flow through. A switch basically allows you to open and close the circuit path, and hence able to actually allow whether the current to flow through in one circuit or another, or not to be able to flow through. The light bulb, on the other hand, represents the electrical component. So this can be, another ammeter can also be another form of an electrical component. A voltmeter can also be. So it really depends on what apparatus are you using to actually formulate inside the electrical circuit. Then, last but not least, you must have an electrical energy source, and in this case, it should usually a cell or a battery. Okay, so in order to represent this particular diagram through a circuit diagram, what we'll do is you take a look at, we have actually the electrical source. So let's say there's only one battery cell, so one long, one short. Then we have the switch. So usually you will use straight lines to represent it, and this switch is actually closed. Okay. Next, you have the light bulb, usually by cross. In this case, it should connect back to the circuit. Yeah. So this is what the circuit will look like over here. So a circuit diagram can be actually used to simplify the drawing of the electrical circuit, like how it was being drawn. So as you can see, it's actually more or less the same. The diagram is doesn't really, we won't mark you wrong lah if let's say your wire is actually put wrongly or too short or what lah. So not to worry, but mainly the conducting wire helps to form the pathway to ensure the electrical charges flow, and these electrical charges can only flow continuously in a closed path known as a closed circuit. When the path has a break point, it is called an open circuit, and these electrical charges would stop flowing. A switch is used to form a closed electric circuit or an open electric circuit. So do understand that there is two types of electrical circuit, one open and one closed. In this case, we could see that for the types of circuit in a series circuit, all the electrical components are connected in a single loop. And in a single loop, there is only one path for the electrical charges to flow in the circuit. So what you can see is over here, the wire, right? I mean the current flow, right, actually doesn't really split into other pathways. Instead, it will actually move from one end to the other end into a closed circuit lah. So a break or faulty component at any point of the path will prevent the current flow in the entire circuit. On the other hand, when you look at parallel circuit, right, is where the electrical components are connected in different loops, and there are more than one path for the electrical charges to flow in the circuit. Meaning, let's say if you look at this electrical path here, it can split to the left, it can also flow downwards. It can split again and continue. And later on, you would see that it's able to join back, flowing up and back to the path. So this eventual splitting, right, this action of the splitting represents the alternative pathway in which the current can flow, and hence it's represented as and it's called a parallel circuit. So a break or fault or faulty component, meaning, right, if let's say one of our component here gets faulty, meaning, let's see, over here it gets removed and there's a break. What will happen is the current will not be able to flow through here. It will not be able to flow through here. However, it will still be able to flow through in this way, forming a complete loop. Hence, electrical current can still happen. And a break or a faulty component in one of these loops of the circuit does not prevent the current flow in the other loops. As compared to a series where, let's say, there's one of the pathways, right, that is being broken, the whole circuit will not be able to actually move at all. So in your usual case for examinations, they will tend to ask you to define like what's the current, what's the voltage, what's the resistance, and to also do the calculation. Not only that, you might be even asked how to go about drawing the pathway of electron flow or direct current. So for electrical current, right, electrical current is really the rate at which the electrical charges flow. And this is actually a measure of the amount of electrical charges flowing through a particular point in a circuit in every second. So in this case, the symbol is not SI unit. How we represent electrical current is by a capital, and the SI unit for the electrical current is ampere, capital A. So this electrical current flowing in a circuit is measured by this ammeter. An ammeter is a device that helps to measure the current flow, and this must be connected in a series arrangement in this case. If it's not connected in a series arrangement, it's actually like maybe in a parallel like this. Then you are not actually measuring the current of the light bulb, and this is wrong. In exam, if they ask you to draw, you must make sure that the ammeter must be connected in a series arrangement. Other instruments for measuring small amount of current can be in the form of microammeter or galvanometer, which is not in your syllabus. So convention current. So there's two types. One is known as convention current. The other is actually a direct current. So what does it actually mean? So before electrons were discovered, right, current was thought to be flowing. Is basically the flow of the positive charge from the positive terminal to the negative terminal. Meaning, you can hear the one in red. So let's say blue. Is where the direction of conventional current or direct current flows. Okay, this is what we call conventional current. In exam, you might be asked to draw. However, for the flow of electron movement, right, this is moving in an opposite direction. So in exam, if they ask for the flow of the flow of electrons, right, it's usually from the negative terminal, as indicated by blue, back to the positive. And if they ask for a conventional current flow, then it will be from the positive terminal to the negative one, as indicated by the red color markings. Um, so using the ammeter to measure the current, the ammeter must be connected in a series with the circuit. And this positive terminal of the ammeter is usually connected to the positive terminal, meaning in the ammeter there is actually two bulbs here. One is the positive end, the other is the negative. This positive end must be in sync with the direction of the positive end of the cell, and the negative end of the battery must be in sync with the negative end of the ammeter. If let's say if you arrange it in the opposite direction, meaning a negative is connected to a positive for the instrument, the needles will be moved in an opposite direction, meaning it will move less than zero, and this will damage the ammeter. For potential difference, this is the other form of mode in which energy is needed to push the electrical charges from one point to another in an electrical circuit. Without this energy, electrical charges will not move, and hence there is no electricity in the circuit. Okay, so what is this amount of energy then? The amount of energy needed to drive an electrical charge across 2 points is what we call the potential difference. And that the definition of potential difference across the 2 points is then the energy needed to move a unit charge to flow between 2 points of a circuit. So you can think of it as like a gradient slide lah, where the steeper the difference in two different points of the electrical circuit, the greater the difference is the steepness of the slope, therefore the flow will be higher. As compared to more gradual flow, which has lower potential difference, therefore lesser voltage. So the SI unit for potential difference is known as volt, VOLV, LT, and the symbol for it is actually capital V. That means the SI unit is actually capital V. So a voltmeter is used to measure the potential difference across 2 points, and a cell of 1 volt would represent 1 joule of energy produced by the cell to move one electrical charge across any 2 points in the circuit. You can use a voltmeter to measure the potential difference, and the voltmeter must be connected in a parallel across the 2 points of the source of electrical energy or an electrical component. So for an example, to measure the potential difference of an electrical energy source, such as a cell, this is done in this manner. Okay? It has to be parallel to the instrument or to the component that you are trying to measure. If you are asked to measure the potential difference of the light bulb, you have to put it parallel to the light bulb. Next one we look at is called resistance. So what is resistance? Basically, resistance is some form of opposition to the flow of electrical charges in the circuit. In this case, the relationship between the three variables we talk about, the resistance, the potential difference, and the current, is represented by resistance equals to potential difference over current. So this can be represented in your distance time graph, distance time speed time kind of calculation, where potential difference or the voltage is at the top, the resistance and the current is actually below. So how you can remember it? You can also remember it as V equals IR, where V is the potential difference, equals to current times the resistance. And the symbol for the voltage potential difference is V. Current, which is the symbol I, is represented by the SI unit A, and R is the omega sign, which we actually call ohms. So a resistor is an electrical component that can be used to resist the flow of electrical current in a circuit. And there are two main types of resistors. One is known as the fixed resistor, the other is known as the variable resistor. So what it does is that for fixed resistor, your resistance is actually fixed and cannot be changed. Whereas for the variable resistor, it can actually fluctuate and be adjusted. So what is the effect on current? They cannot vary the amount of current flow in a circuit because it's fixed already. Whereas for a variable one, or what we call a rheostat, another name, it can vary. So when we talk about how do we go about varying, like for example, some of those light bulbs where you can control the knob, those and when you control the knob or you turn the knob, the light will actually become brighter or it can become darker. So this is where it's actually a variable resistor working. Another one is like maybe your volume, the volume of like when you hear your earpiece, the volume you want it loudness, then you reduce the number of resistance. So you dial the volume down lesser. You want more resistance, then of course you just reduce the sound, then it will be softer. Okay, so resistors are generally can be also affected by a few things. Number one, the length of the wire would further increase the resistance, whereas the thickness of the wire would also adjust the resistance. So how so? So I usually like to use the analogy of a road. A very long road, right? The amount of then the cars on the road represents the charge. So current is basically how fast this car can move from point A to point B, right? So having a very long road, the time needed for the car to move from one end to the other end is slower. So that could also be implied that the longer the road, there is more resistance. So same thing for wire, the longer the wire, it will actually formulate more resistance for the electrical charge to move from one end to the other. Thickness will represent the how many lanes the road will have. So having a very um, wide road, right, which means you have a very thick wire. This will represent that you have a lot of cars actually able to move at the same time, and this speeds up the whole flow of traffic. As compared to having a thinner wire or thinner road or less wide road, this will actually result in us having more resistance. Why? The whole overall flow of traffic is actually slow because there's lesser space of movement. So generally, you might be asked how to calculate resistance in a series as well as in a parallel. So in a series is very clear cut. You just have to add them up all together. So the summation of resistance on the resistor would represent the total resistance, or what we call the effective resistance. Okay. However, when we talk about it in a parallel arrangement, then it's different. Then comes into this point whereby the sum of the reciprocal. So what is reciprocal? The sum of the reciprocal represents 1 over. The 1 over that value is the reciprocal. And do remember that this also meant that the total resistance will have to also be a reciprocal, in which eventually you have to flip it back up, because what you are finding is not the reciprocal of R total, but mainly R total. So this is one step that a lot of students tend to actually miss out or forget. Okay, so and from this what we can see the relationship is that when you have more resistors added in a series, right, the total resistance will actually increase a lot. However, the resistors when they are connected in parallel, this will reduce the overall value of the resistance, and in this case, this will actually reduce. So how does it translate to the current? In a series, by adding more resistance, the current would actually reduce because the resistance increase. However, when in a parallel arrangement, when you add more and more resistance or resistors in a parallel arrangement, this would actually overall reduce the effective resistance because of the relationship, the reciprocal relationship, and hence the current would actually increase. So the light bulb will actually be brighter. For the other types for current and parallel arrangement, right? For the current, you will see that in a series, the current is actually the same throughout whichever part of the electrical appliances is at, or the electrical circuit is. For parallel, you have to add them up together. On the other hand, for voltage in a series arrangement, you have to add the individual components together, whereas for parallel, it's actually the same. Okay, you can pause the video here if you want to rest a bit. The next one we'll be discussing is more on the effects of the electrical current for the different kinds of scenarios, in which you will need to know how to explain and elaborate with an example of how the energy is being changed from one form to another and how it's being used. So now let's continue. So the effects of electrical current, the first effect is usually heating, meaning we use electrical energy, converting it into heat energy. And this is where you get things like your electrical iron, your kettle, examples in which we use electrical energy to convert into heat energy. So the resistance of an electrical conductor will cause the conversion of the electrical energy into heat energy when electrical current flows through it. The greater the resistance of the electrical conductor, the greater the amount of heat energy produced. Different electrical conductors will have different degrees of resistance. For example, nichrome will have a higher resistance than copper. Therefore, nichrome is used as the heating element in a kettle. Copper is used as the conducting wire. And certain electrical conductors, like a tungsten, will be able to give out heat and light simultaneously when current is actually flowing through it. And we can see that tungsten has actually quite a high resistance. Next, we can use electrical current to induce magnetic effect, meaning you can create a temporary magnet. So if an iron bar is wound around by a conducting wire which carries electrical current, this iron bar will be induced to become a temporary magnet, known as an electromagnet. The iron rod becomes an electromagnet when the electric current flows around it. So the electromagnet will lose its magnetism once the electrical current stops flowing, and then the electromagnet is used widely in our daily life, such as in a telephone, lifting heavy steel or iron objects, electrical motor, and bell. These are examples of how you can go about using it. So an example, a very common one that in exams they like to use is the electrical bell, in which at point A, you would see that it's an open circuit, so there is no electricity. And when there's no electricity, no sound is produced, meaning no one going to press the doorbell lah. Reason being is because there is no point of contact yet for the hammer to hit the bell. So when the switch is closed, meaning you go and click the switch, right? Or press the switch, the circuit is complete and electricity starts to flow in the circuit. The iron core becomes an electromagnet and therefore pulls the hammer to hit the bell. While the hammer moving towards the bell, the circuit is discontinued at the same time. And this is because the contact point at B is open, so if it breaks, the circuit electromagnet loses its magnetism as electricity stops flowing. The hammer would then return to its original place when it is no longer attracted by the iron core. This contact point closes up and completes the electrical circuit again. The cycle will then repeat until the switch at A is actually open. A chemical change caused by electricity is also called electrolysis, and an electrolyte is a liquid or a solution which can conduct electricity. So the electrolyte will undergo chemical change when electricity passes through it, and electrodes are electric contacts which allow electrical current to leave and to enter the electrolyte. So this is in a way something like electroplating. Okay, so electrolysis is also widely used in electroplating and in the extraction of metals. So how is it usually done? In electroplating, an object is coated with a layer of metal. The object to be coated is usually connected to the negative terminal of the battery or the power supply, and the metal to be coated is connected via the positive terminal. So this purpose for electroplating an object will allow maybe the object to be more shiny, or to even prevent the object that is made of iron and steel from rusting. So it forms a protective layer. Metals can also be extracted from their impurities by electrolysis, which is actually at the end of the day, you need to know this word for electrolysis, where the impurities containing the desired metal is then connected to the positive terminal of the power supply. A thin sheet of this pure metal is connected to the negative terminal of the power supply, and that the metal from the impurities will eventually coat on the surface of the thin sheet of the pure metal. And in this case, the extraction of copper from the impure copper sample will then be taken. Okay, so that comes to the end of the first part of electricity. You can watch the next video for the second part. That's all for today.